Welcome, everyone. Thank you for joining today's webinar about recent RTAC and Axion advancements for RTU and substation gateway applications. My name is Tristan Beaudois, and I'm a marketing program manager from Pullman, Washington. Before we start, I'd like to bring just a few items to your attention. This webinar will be an hour long, including questions at the end of the presentation, and a recording will be available on our website shortly after. During the webinar, all participants are muted, but if you have any questions throughout the presentation, you can submit them in writing to all panelists with the Q&A tool at the bottom right-hand corner of the application. Any questions that aren't addressed during the live event will be answered later via email. Our presenter today is Darren Kites, and we also have Mark Weber, Chris Bontje, Isaac West, and David Presswich joining us today to answer questions throughout the presentation. Darren Kites is an engineering manager at SEL, where he is responsible for the RTAC and Blueframe automation and software platforms. He has worked in research and development at SEL for over 10 years, supporting the development and application of various automation products. Darren earned a bachelor's in renewable energy engineering from Oregon Tech, as well as a micromaster's in digital product management from Boston University. And he is a certified information systems security professional. Now I'll go ahead and pass the microphone to Darren, and we can get started.
Thanks everyone for joining. Appreciate your attention today. My name is Darren Kite, and today we're going to be talking about the RTU application in the RTAC, which is really the core function of the RTAC platform. People use the RTAC in a lot of innovative ways, but this is really the application that SEL started in, with the 2020s, evolving into the 2032s. And kind of culminating into what we call the RTAC today, the real-time automation controller. So with that, let's get started. So the way that we really thought about the RTU and the substation has changed over the years. SEL has really changed our focus into making very reliable hardware and then allowing customers to choose which software goes onto those products. The installation cost of an RTU, of installing an RTU in the substation, far out exceeds the actual cost of the RTU. So with that in mind, we design our hardware for 20 years, and we want to allow our customers to use that hardware however they choose over the course of that lifetime. So with our hardware, we're really focused on scalable performance. We have a whole range of products that meet the application needs, depending on if they're a distribution substation, a generation site, or a transmission substation, or even a recloser cabinet. We focus on our reliable design. Again, that's where that 20 years of design lifetime really comes in. We put a lot of effort into vetting our suppliers, ensuring that our supply chain is secure and comes from trusted manufacturers. And this goes back to the way I really started this slide here, upgradable platforms. All these platforms are upgradable by design. If you look at the top picture where it shows a SEL 3555, you'll see that panel has little thumb screws where you can take off that cover and you can replace the SSD and upgrade the platform. And that can go from Windows to an RTAC, and maybe from an RTAC into a Blueframe platform in the future, right? And then you can upgrade your substations without having to incur that upfront installation costs. And these platforms are designed to continuously evolve. Every 3 to 5 years, we go through and modernize the components, and that usually means more CPUs, more RAM, bigger SSDs, etc. So these platforms are designed to keep the same form, fit, and function, but also keep you modern with the latest technology. So the platforms that I'm showing you on this slide here are modern platforms, and that includes the 3355, the SEL 3355, the SEL 3560, and our newest edition, the SEL 3350s. Well, we continue to maintain and manufacture the 2241, the 3505, and even the 3530-4. But over time, we'll also focus our attention to modernizing these platforms as well. And the next one on the list is creating a new CPU module for the Axion platform, which we'll talk about here very shortly. So just a quick overview of how the specs stack up against across the product range. So SEL always strives to maintain that really wide temperature range from -40 to 85 C. On the top end platforms, you do have a top range of 75 C, but you can really see how the performance in the CPUs increase. So when we started out, we were starting out on a 1-core 533 megahertz platform, and that was in the 3530 and the 2241. But over time, we really shifted into a much more powerful platform. So the 3350 has an Intel quad core that starts out, that is 1.6 gigahertz. The 3555, which is the top performance tier, is an Intel Xeon server grade CPU, has 4 core, starts out at 2, but goes to 2.2 gigahertz. And the memory, the RAM that gets installed in the units, as you can see in the 3530s, starts out at 1 gig. In the 3350, we jump to 8 gigs. And in the 3555, it's configurable anywhere from 8 to 64 gigabytes of RAM. The storage also has increased over time. Again, when we started out with 3530, it was 2 gigs, which was sufficient. But as the application and data needs in the substations really increased, we can go up to now 2 terabytes in the 3350. And in the 3355, you can have multiple drives, and you can configure the data drives in a RAID 1 configuration to make sure that data is never lost. With the new platforms, we also added the capability to connect a monitor into it, so that there's no need for a second, substation computer to render an HMI. So we have a display port on the 3350. We have a display port and 2 DVI-Ds on the 3555 and 3560 platforms. And the performance is really, shown in the specs. Compared to the 3530, the performance in the 3350 is 4 to 6 times more. That ranges depending on the applications that you're running the RTAC as. But you're looking at boot up times that are less than or in the range of 30 seconds. Same with the 3555, where you get the performance that's 6 to 10 times more performant than the 3530. Again, the boot up times when downloading a project or when there's a power cycle event or etc. it is 30 seconds or less in most cases. So the 3350 was the newest addition to the RTAC family. And we'll just kind of review this. This launched a year and a half ago, but we'll review the specs just to give you an idea of what I'm talking about. And you'll see in the coming slides how we've even enhanced this with a release that's about to release in one day. So we have the display port on the left. We have 4 USB ports on the back where you can hook a keyboard and mouse. They do only have default drivers, so you can't hook a USB drive in there. It's only for the keyboard and the mouse. We have the RJ45 serial ports. So we switched to an RJ45 connector for our serial ports to really get that density, and you'll see why here in a couple of minutes. But you can have 16 serial ports in a pretty small surface area. And then we have 4 Ethernet ports on the back, and there's also 1 on the front. And these can be configured in copper or SFP versions. We have a BNC input and output for connecting iRig. We have a DI-DO function block or Euro connector on the back. And the DI can actually function as a battery monitor. And it's the same circuit that's used in our 400 series relay. So if you are doing battery monitoring substation, you don't have a 400 series relay, that will function the same way. And then we also have a reliable power supply. Again, same power supply as we put in our 400 series relays. So our newest platform that we're going to be releasing tomorrow, in fact, you can order this tomorrow, is the 3U version of the 3350. And the 3U version offers you additional I/O boards, and we have the choice between you can order one, none, or all of the I/O boards. So we have a contact I/O, 24 software selectable, universal DI, and 8 DO. So you don't have to select the voltage range when you order. You can do that through the software. We have the second board that we offer is a serial board that has an additional 32 ports, 32 serial ports. So that brings the total serial port density up to 48. If you're familiar with the SEL 2032, that could replace 3 2032s. We offer redundant power supplies. And also, as I mentioned earlier, we have that DI that can act as a battery monitor with 0.5% DC accuracy. So this is a great option for those legacy substations, or even if they're NERC medium impact stations that some customers have chose to keep on a serial bus. This can really, decrease the extra equipment that you need to integrate all those serial relays in the substation. With all the modern platforms, you can connect them to the Axion I/O, and we have a range of I/O modules. So digital input, output, AC metering, AC protection. I'm not going to read them all. We have a full complement of I/O modules. And you can connect up to or have configured up to 60 modules, over 1,000 DIs for the AC protection module, anywhere from 16 to 32, depending on the performance specifications. So it's easy to add I/O to an existing RTU and really expand it as your needs increase or decrease. And with the I/O modules, we also create there's a lot of D20s out in the electric power system now, and they're starting to age out, and GE's even dropped some support for them. So we do make conversion or cabling kits to easily connect the DB25s together and then land them with Euro connectors on the Axion module. So pictured here is the DI hooking into the field wiring through that DB25 connection. We also have an option where you can land it right onto the West term board. So you can replace the resistor networks with jumpers that come in the kit, and then hook the Euro connectors right onto the West term board. This is showing an analog module or the periphery of the D20 retrofit. So it takes 2 Axion modules to fully incorporate the analog inputs on the D20 analog board. And we also have kits that allow you to integrate the DO using the interposing relay board. Just hook the DB9 connector right in there. The cabling kit has cables or landings for wetted power supply, so you can integrate the wetted power supply into the DO board. So if you have any questions about the D20 replacement kits, feel free to reach out to your local application engineer, and they can help you select the right cables, order them up. We do even make customizations for customers when requested. And this an additional hardware component that we've also added is the 3390T. This is a PCIe connect card that goes into the 3555. And this allows you to land the B and C input outputs onto the 3555, but it also has 2 Ethernet ports that function just as all the Ethernet ports on the 3390 E4 card. You can extend those with the Axion module, so you can enable one of those ports for EtherCAT, so you can run your I/O modules out. But the really cool thing about this new PCIe card is it also functions as a PTP high accuracy time input, so you can bring in PTP and then synchronize all your devices downstream through iRig or any number of protocols. And that does have that high accuracy, so less than 1 microsecond. So it serves for those synchrophaser use cases. Now we're going to switch gears and go into the SCADA and RTU functionality of the RTAC, and we'll walk through several sections that are pertinent to the RTU use case. But the core functionality of the RTU, right, is either landing I/O onto the inputs or outputs, or collecting digital data and transforming that and giving SCADA a connection to collect all that data and to exercise controls. So one of the most critical functions of that is mapping tags. So we did release or data points. So we did release a new mapping application that simplifies mapping. So when you configure it, you add your clients, and then it will automatically create a SCADA map for you for those simple applications. And it also allows you to do no hassle control mapping. So we'll automatically create mappings between the opera pulses or the trip close functionalities, latch on, latch off, pulse, etc. And it also allows you to configure control pairs. So if you have a trip close pair, then it's really simple to map those pairs to a single control. And in this new application, we also added, just get me to the pointer options here. We also added this operator column where you can easily configure scaling of value, failover between points on the digital inputs. You can add timers. You can invert points really quickly and easily without any kind of logic. And it even makes like logging the data into the SOE and setting live data super simple. This does output a Excel file or a CSV file that has all the mappings that you've configured. And then by August of this year, we'll also have an input. So you'll be able to take that output, that CSV, modify it however you want, or create your own maps. We have a lot of customers that use the XML features of the RTAC project to export all the tags, recreate their own tags, and bring that in. But we'll allow you to export the CSV from this application and then import that into the application. So you'll be able to create your own custom maps. And then once you import it in, modify them however you choose in one easy interface, configuration interface. Along with that, the HMI is a pretty critical function of the RTU. We have been enhancing and working on the HMI over the last couple of years. And we have these new features, which you can see in this picture here. You can go to our SEL video support website and watch these videos of how to configure some of the features that I'm talking about now. But we added a feature where you have tag substitution, right? And so tag substitution allows you to create a single screen and then export those tag mappings to Excel, or you can do it right in the configuration interface and create multiple mappings into the same screen. So it allows you to reuse all the work in creating that perfect screen that you want, and then tying different sets of tags into it. So if you create a great screen for, a 851 relay, you can keep reusing that screen and then just substituting the data in there. So it allows for a rapid configuration of HMI screens. And we've also added an import-export tool for CSV. Customers still love using CSV and all the tools that Excel gives you. So we wanted to really take advantage of that. And so we allow you to export all the tags in the HMI out and then make your modifications in the CSV spreadsheet and then import it back in. This is just going back to the 3390T card. We do have support for PTB high accuracy, as I mentioned, but that's also on board the 3350 and the 3355 on all the standard Ethernet ports on the 3390T and the 3390 S8 card or E4 card, excuse me. So this is another really key feature of the RTU. It allows you to bring that time in and then distribute it over DMP, 6870, iRig, NTP. So SEL does on even the RJ45 or the DB9 connectors. We on all the serial connectors, we allow the iRig signal to pass through. So it creates a really good integration piece for your clocks to allow you to bring the time into the RTAC and then have the RTAC's connections synchronize time. We put a lot of effort in over the last 2 years into 61850 and bringing that up to modern standards. The RTAC is certified for Ed2, 61850 Ed2, and we've added some really innovative features for mode and behavior support. So this way you can put your RTAC and your substation in test mode very easily. We added support for local and remote mode, which is processing the ORCAT information attributes coming in from the MMS client that's interacting with the RTAC. We now auto-generate the LGOS logical nodes for Goose messages. So that allows easy visibility of Goose messages to do diagnostics on. And we do have some plans for integrating and creating reports and visualizations for doing critical communications in the substation. So stay tuned for that. We also added support for set point service, which functions a little bit different than just a normal analog control. And that allows us to incorporate more and varied data types. On the MMS client side, we added support for functional naming. So that allows you to replace the IED name or the device name, the IED name with a functional name, and then act on that name when you're talking to a remote server or an IED. And so that also supports set point services. And as I mentioned, we have new data types for integrating more MMS servers. And the cool thing about how we implemented test mode, it gives you several strategies to be able to put the RTAC in test mode. So you can configure it to have a touch button on the front display, or a test switch that initiates the test mode functionality. You can also use a SCADA protocol to initiate it, or an MMS command. So lots of different ways to put your substation into test mode so that you can commission and validate your substation. We added simulation support for Goose along with that. So again, that helps to commission substations rapidly. And we allowed multiple Goose messages. We allowed you the choice to map a Goose message to an Ethernet port. So you can have several LANs that are segregated in a Goose strategy, and then you can map those between the individual Ethernet interfaces. We added our newest protocol that we added was OPC-UA, and this is a really great protocol for being able to connect to an RTAC and browse in all the data that you need to see. And I really think this is a great way without doing predetermined mapping to exchange data between RTACs. So this is supported on our modern platforms, the 3350, 3355, and 3360. Supports multiple connections. The really cool thing about it is easy discovery and mapping. And you can do that on the fly without having to configure the other RTAC. So all the data in the logic engine or any of the diagnostics information through the POUs is available through the browser. Now we're going to shift over to asset management. This is really becoming more and more important as people deploy. More substations are coming online. That means more devices, more RTUs to manage. And we really wanted to focus our efforts in making the substation, all the data in the substation available so that you can incorporate that into your compliance plan. And also to make the RTU itself easy to manage. So there are more devices in the substation than just SCADA devices. So those could be switches, those could be routers, they could be firewalls, and those devices use different protocols. So we have a whole suite of IT protocols, the SNMP manager and SNMP agent, so it can be both a server and a client. So you can go out and collect all the switch statuses from your, the port statuses from your switches. We also have a syslog client aggregator, so you can digest the incoming syslogs, log them in the SOE, and then serve them back out. So to an application, a SIEM like Splunk or any other SIEM that you want to use. And we also have a syslog server that just, again, that integrates into the Splunk. So you can integrate all the substation syslogs coming in and then serve them out and also log them in the RTAC SOE. And we did increase the SOE limit in the RTAC to 500,000 to better incorporate that feature. We've been spending a lot of time thinking about how to make devices easier to manage. We have a lot of customers that spend a lot of effort on compliance. Some will go out to the substation or access it remotely, do screen captures. They'll do project and digest by exporting the XML. A lot of different strategies out there, but we really wanted to make it easier. So we started adding APIs in the RTAC about two and a half years ago. And this was really so that you could programmatically access the RTAC's data and pull that out so that you always had an up-to-date record of all the information for compliance. If an auditor stops by or if you didn't have the information you needed at a certain time, you can easily go out and get it from the RTAC through these APIs. And an API, these are REST APIs, they're HTTPS, so they're encrypted APIs. They require the same authentication. So it's much like using a web browser without the web browser. And these are open, they're documented in the RTAC's webpage. So you can code against these yourself. You can have another vendor's solution code against these APIs, or you can use our DMA products, our Blueframe DMA products to access these APIs. So we have APIs for reading the whole configuration for the network, the port statuses, whether the ports are open or closed, how the networks are configured, whether the web interface is enabled, etc. Right? You can read the project, all the user role statuses, etc. You can pull all that information out, and in many cases, you can also write that information. So the next APIs that we're really focused on are the APIs for configuring the X509 certificates and also for firmware. So the firmware API is something that we're really excited about also, because it'll allow you to stage remote firmware, remotely stage the firmware, and then upgrade it at your leisure. Now, a lot of people don't have IP connectivity to the substation, so we wanted to make that same information available over serial. So all the APIs that I just described, you can access through the SEL server or through FTP if you have Ethernet connection or an IP connection, but don't have access to programming tools in your DMZ, then you can just pull it out by FTP also. But what this is showing you is over a PuTTY connection. It could be a serial or a terminal connection using PuTTY, pulling that data out for applications like Tripwire that are used to working with the command line interface. Well, as I mentioned, we have our own set of tools to be able to monitor and manage the RTACs along with SEL relays, and those are the DMA suite and the SEL Blueframe platform. And this is showing you how Blueframe is going out, or DMA, this is configuration monitoring in this case, is going out, pulling the RTAC project back, giving you change notifications. So over time, you'll see more and more Blueframe applications that use the RTAC, and I'll be talking about one in a minute. But the DMA suite is really suited for managing large sets of devices, let you know when they change and pulling that data out. So if you're interested in DMA, please, we've had several webinars on that in the past, so please just go to the SEL website and search for the DMA webinars, and you should be able to pull those right up. We also have APIs. This is, again, is for compliance. Since the RTU is in that central data location in the substation, right? Almost all the devices are connected to it so that it can collect the data. It's a really great place to collect even more compliance data from your substation. So we do have tools that will go out and scan an Ethernet network, tell you which devices are on the network, give you an IP address and MAC associations, tell you if you have duplicate IP addresses, and also enumerate all the TCP and UDP ports that are open. So this is great. Again, if you get caught in an unexpected audit, or you during the audit procedure find out that you don't have the information you need, you can kick off this scan, get back the results to complete your compliance profile. In our latest firmware release in R151, we added a lot of cool tools to allow you to troubleshoot RTACs remotely. And I'm going to show you a couple of these tools, but we'll go through the slides and I'll switch into a live demo to show you a couple of these. This is a Blueframe application. Again, it's using the RTAC APIs that we built into it, and it's meant to show you system-wide visibility of your substation. So you can go down there and see if your RTACs are online, and it's kind of like the classic troubleshooting step that would kind of happen, right? Is a lot of the substation comms guys will come in the morning and they'll get notification from the SCADA team. And they'll say, well, I have a bunch of comm alarms. Well, the RTAC dashboard is meant to help speed up that troubleshooting. So you would come to the RTAC dashboard, see that your RTAC is communicating, see that you have comm alarms on an RTAC or maybe multiple RTACs, depending on maybe you had an issue in your comms network that caused a widespread outage. And then you could go down and actually see which devices are connected, which devices are online, which devices are offline, and do more detailed troubleshooting. So this is the kind of the second step, or remote or locally, you can go to the RTAC's webpage, right? So you would navigate to the RTAC's webpage. You would see your, this is the connected ID page in the bottom half of the screen, and you can see the on and offline statuses of the devices, and then start doing detailed troubleshooting. Or you can pull up live data and see what your contact IO is doing also. So we have these tools that allow you to see live data that do detailed comms troubleshooting. You can download the active projects, and you can even generate, device communication profiles from the SDN. So we're adding a lot of capability to speed up configuration and troubleshooting in the substation. And this is a really cool feature that got a lot of people excited. So now in the RTAC, we used to, and we still do have this capability where you can go and when you're troubleshooting a connection, you can download the Wireshark or a PCAP and open that PCAP up in Wireshark and do really detailed troubleshooting. We also offer that same functionality now in the RTAC's web interface. So without needing any separate software, you can start troubleshooting either remotely or locally any comm issues that you're going to have. So let's go ahead. This is better if we just do a demo on this. So let's go ahead and show you what this kind of looks like. So here, this is the RTAC dashboard, as I mentioned. This is a Blueframe application. It is a free application you can download and start using on Blueframe. The expected release date is sometime in April. So this will be open for anyone to access and use. So this is showing you right here kind of a view of all your resources, and these aren't sorted in folders, but you could sort these over here in folders by assigning the unassigned. So these are devices that are not online. So we'll come over here and we'll search for an RTAC that we have particular interest in. So those are the Midvale ones. And we'll see, okay, well, I can talk to the Midvale ones. I know exactly what RTAC it is. I know the firmware version on it. If you can see on this device panel over here, let me go ahead and switch to a better pointer option. Oh, can't do that here. Hopefully you guys can see my pointer. And you can see the device model. You can see device statistics. You can also modify this visibility to give you additional data. So you can come over here and say, I want to add a column, and maybe we'll pick how many users are logged in. So we'll go down here and click on users logged in. We'll apply that. Okay, now we'll close our detail panel. Now we can see the number of users. Maybe I'm interested in certain firmware versions. So I'll go back here, go down to the firmware version, add a column style, and maybe I want to see the RTACs that have R151 firmware installed, and to make that visible, I'll go ahead and make that green, and then I'll add that. So now you can see all the RTACs in these Midvale substations have R151. Now, if I take away my filter, right, you can see now it's more visible to see which RTACs have the firmware that I'm looking for. Okay, so let's go back and do some more detailed troubleshooting. So I'm going to go, I see that I have 8 COM alarms on the Midvale, so I'm going to go ahead and launch into the detail view. Again, it shows me all the information about the RTACs that I've selected, the project, the users' names, and I can see I have comms offline here. So that's concerning. If I had direct resource management, again, you can go and reference the DMA webinars where they go over direct resource management. I could launch a web connection directly to my RTAC. But since I don't have that configured, I'm just going to manually navigate to my RTAC. Again, this is the same RTAC that's being displayed here. So I'm going to go down here and continue my troubleshooting. And I see I have some connections here. This is the connected IAD page that you can, again, if you have a mouse and a keyboard, you don't even need a separate computer. You can do this right on board the RTAC. And I want to do some troubleshooting. So I see I have an SEL client here. So I want to go ahead and see if I can ping that SEL client. And I can ping it. I'm getting a good response, so no loss. Now I want to go ahead and check the ports. So I have good connectivity on it, but now I know that the IP address there, I know I'm connected to the correct IP address. I can go ahead and see if the port is open. So now I just checked and see if the port is open. And now, okay, yep, the TCP 23 is open. I could start a network capture here, which will download at the very bottom of the page. And I could take that offline in Wireshark and do detailed comms diagnostics. But I can also do that right through the web interface now. So I have this DMP server that's offline. So I want to go ahead and do a packet inspection on that device. So now I start to see the packets come through, and I can use the same filtering that I use that I'm accustomed to in Wireshark, and I can start to filter the DMP traffic. And it does not look like I have DMP traffic coming through right now, so that's probably the problem. Right there, it just came up, so a little slow there. Now I see that I have DMP traffic on that connection. I can do detailed diagnostics on it. I can go down here and see which objects are in the response, etc. So this allows you a lot of capabilities to do remote or local troubleshooting without needing a laptop or TCA if it's a NERC substation. And so it does make it quite easy to get in there and find the problem and get out quickly. And if you, many people already know about live data, but you can also do the same thing with any data point that is configured on the RTAC. You can enable that for live data and make all that data visible so that you can come in and see exactly what you need to see quickly. Okay, back to the presentation. So I'm going to kind of belabor this a little bit, but with that connection, that video connection and mouse and keyboard, you can really start to turn the RTAC, that RTU place that has all the data anyways, connected to SCADA into an engineering workstation. So you don't have to bring in those TCAs, or if a tech goes through your substation and doesn't have the laptop with the correct software. So this is also showing you that you can access all those troubleshooting tools that I showed you, but you can also access other devices' web pages in the substation. And you can do this remotely too. So the RTAC can function as a protocol break. So you can come encrypt it over TLS into the RTAC and then have the RTAC proxy that connection and give you local or give you access to the local connections behind it that may not be encrypted. So that functions as a protocol break, but it can also access in the substation over keyboard and monitor web pages that are local to it also. And then we have the SEL terminal, which we've added a lot of capabilities to the SEL terminal. So you can see that this is very reminiscent of a 2032. So you can do the who command and the port command, and then get access down to the SEL relays. If you have it configured and you have the permissions set correctly, then the RTAC knows the passwords for all the SEL connections, and it can log the user in if they have the correct permission down to the relay, so that anyone accessing the relay doesn't need to know the passwords as long as they are authenticated to the RTAC. It has a password rotation interface. And you can also, as I showed you, see all the configuration monitoring that is available via the API. So a lot of capability that can be accessed via Ethernet or serial connection. And so we have some features planned for later this year, maybe into mid next year, for integrating a terminal, just as I showed you that protocol dissection interface. And the live data will integrate a terminal in there to really kind of round out that engineering workstation use case in the substation, right? If we can remove Windows, that can decrease O&M. So if we can remove any computer that has Windows that you need for accessing other devices, that's a win for everyone. So kind of closing out the presentation, we were really focused on the RTU functionality of the RTAC in this presentation. But there's a lot of other things you can do. When you're located centrally in the substation, like the RTU is, and you have connections to all the devices, you can get a lot of value. And that's becoming more and more, important as the compliance requirements increase over time, or the needs for data. It is really about data these days. That's what more and more customers are saying. I need to get to that data. I need to, decrease O&M, give my engineers and my techs easier workflow so they're not spending their time retrieving all this information manually, right? So the RTU is really well positioned in place to monitor the, setting changes in devices. This is really easy over SEL protocol, but in many cases it can be done, via Modbus or 61850 MMS file transfer. You can collect events and over multiple protocol interfaces. Most IADs, protected relays out there, have event interfaces that can, that you can collect data over. And this is really easy over MMS file transfer or FTP. So if your devices support that, there's the barrier of getting that information is really low, and you don't even have to be using necessarily MMS in the MMS file transfer use case for data collection or for SCADA data collection. You can just use it to transfer data. You can also use it as a PDC, right? Again, if you have SEL devices, we've been incorporating synchrophasers in our products since the early 2000s. So you can get all that data and use it for other compliance like NERC PRC2. And there's a wealth of information in devices, whether it be breaker reports, transformer reports. You can extract that for, condition monitoring. It's not the point of this webinar, so I'm not going into details too much because we'll have an upcoming webinar for our DFR Plus application, which will cover PRC and PRC2 and PRC5. But it is important to know that as the computing power of devices increases, right, and this is true of RTUs, it's in true of almost all devices in the substation now, we can do more with them. And the more you can do with them, it increases the value you get out of the devices that you're installing. and it can also help you decrease O&M. So we have more and more people talking about, I need to get the data, all that data that I just described, and even the SCADA data, the synchrophaser data, out of the substation, and I want to move it to a data center where I can do analytics on it, right, to get more value out of that data. Through all of the functionality that I've described, it's really simple in an RTAC to integrate and pull that data from the substation, whether it be security, whether it be asset monitoring, whether it be for NERC SIP compliance, or whether it just be, just plain SCADA data, right? You can pull it out and move it to a centralized location over SCADA protocols, file transfers, etc. And you can really start to get more data or more use out of the data by taking this integrated approach. So with that, I think we're just about at time for questions. So we'll open it up. If you have any questions, please put them in the chat and we'll get to them as quickly as possible.
Thank you, Darren. Now that we've arrived at the Q&A portion, we have about 15 minutes. As Darren mentioned, you can still submit questions to all panelists with the Q&A tool at the bottom right-hand corner of the application, and we'll be answering those in writing and also have time to discuss a few of those live now. So I'll go ahead and pass it over to Chris to lead the live Q&A.
Thank you, Tristan. Darren, yeah, we've got some great questions queued up here. One question came in, and it had to do with the possibility of configuration wizards in Accelerator and RTAC, and if that's something we've considered for things like point mapping as well as building larger projects like digital fault recorders.
Yeah, that's something we're doing right now. So we have something called our extensions, and that simple tag mapper that I showed earlier is an extension. So over time, we've been building workflows for emails. We have one for report generation. We have a CTPT monitoring application, the simple tag mapper, the dynamic disturbance recorder. All those have been custom configuration engines through the extensions. So we're going to continue to build those out. This is really coming when you want to build an application in the RTAC. The RTAC has a lot of tools to do a lot of powerful things. And the extensions are really taking those tools and making simple configuration workflows. So if you have ideas on what you want to do, send them to your local AE. They'll get to us, and we'll probably start a conversation around it to build one of those. So what we're really focused on right now, again, part of the webinar was to get that data out. So we have a slew of condition monitoring workflows that we're going to be adding for device monitoring, for settings and data extraction. So again, stay tuned. We're adding those, probably 2 or 3 of those a year. So if you have some ideas, let us know.
Very good. Okay, so the next question that came up was, does the RTAC support all OPC UA security modes, encryption, authentication, user password, certificate, etc.?
Not currently. So the first release of OPC UA didn't have security, didn't have the encryption or the authentication over passwords, but we intend on adding that over the next year.
Great. Another good question that came up. I think you briefly touched on it, but what is the official product release date of the new 3U 3350 RTAC model?
So it will be available for ordering tomorrow on March 23rd.
Okay, another good question that came up was the web-based packet dissector using Wireshark formatting. Is that available only for the 3350, or is that the entire RTAC product family?
It's available. That's a really great question. So the packet dissector is available on all modern platforms. So it's the 3350 and the 3355 and the 3560. So again, we'll be looking at refreshing the 2241 next.
Okay, another question came up, which I believe the context was discussed in the configuration monitor or the fingerprint API. And the question specifically was, how are we detecting settings changes and what do we consider to be a change setting?
Yeah, so the fingerprint API, so there's two APIs that you can use for that. We have a configuration API, which kind of is a superset of all the APIs. So you can pull that and get detailed change information if you just have a simple diff tool on it. The other way is the fingerprint API. So this is a complete hash of the database and all the web settings. So if any configuration changes happen in the product, then we'll let you know through that fingerprint API. So again, that includes like all the web settings and all the project settings.
Okay, so another one I'm looking at, I'm just kind of looking at the remaining questions. Along the lines of eliminating Windows workstations, has SEL looked into providing a non-Windows OPC or ODBC historian and report generator on the non-Windows RTAC platforms? So I think this is referring to, OPC Classic that would have been installed on Windows workstations, and if we've ever looked at integrating that.
Yeah, so not the classic version. We are limited, probably for the best of everyone, to OPC UA, which runs on Linux platforms. However, we are going to be adding a time series database to the RTAC in the coming months. So stay tuned for that. That'll be focused at 3 kilohertz data from the protection modules and also synchrophaser data, but will likely expand to other SCADA type data. So you'll be able to extract that via the APIs or the web interface. And that'll be covered extensively in the next webinar that we're going to be doing in the RTAC, the DFR Plus webinar, which Isaac West will lead. But so we are integrating a historian that you'll be able to pull that historical information from.
Very good. Another question. There's actually several of them kind of together being asked. Is the 3530 being sunsetted, and therefore is it not recommended for new installations? Another question is there a last time buy set for the 3530 and the associated 3530-4?
So yes, the 3530 there will be a last time buy letter coming out within a matter of a week. There will be a long-term ramp on that last time buy letter. That was why we were really focused on releasing the 3353U so that people would have a replacement product. The last time buy letter does not apply to the 3530-4. Since we do not have a form factor replacement for it, we're going to continue selling that product until we have a light product to offer in its place.
Very good. Kind of associated with that, is there any chance that existing RTAC models will be upgraded with regards to hardware capability? For example, the 3505 that could be used for smaller projects.
Yes, so it is part of as we're modernizing, going back to the beginning of the presentation, as we're modernizing the RTAC platform, we're working through all the models. So the 2241 is up next. That's the Axion CPU. And then following that, or likely somewhat in parallel, will be the 3505 project. So we'll be modernizing that platform as well.
Okay, another question that I think actually came up a handful of times here. Where did that go? When do you estimate SEL will have a DB9 panel plate to interface with the 3350's RJ45 serial ports? We want to be able to maintain our existing DB9 cables, C273A, etc., when upgrading a 3530 to a 3350.
Yeah, that's a really great question. I was intending on bringing that up if someone did not ask it. So we do have cabling options that are released today and a mounting option released today. You can find that on our accessories page, on the RTAC page. We will have a panel, likely a 1U mount panel that you can slide into a 19-inch rack within the coming months. And that'll allow you to plug in your transceivers and run your RJ45s into that 1U 19-inch panel mount. Or I think there will also be a DIN rail option on that. So you'll be able to cook your transceivers right into the DV9, run your RJ45s right into the top or the bottom, depending on how you orientate the mounting option. So that should be in the coming months. We're working on it right now.
A couple of questions came up along this variation. The Blue Frame platform, we're obviously noting that here as running on SEL hardware. Can that be ran on regular PCs or other virtualized environments?
Yes. So Blue Frame, you have a couple options on that. You can run it on the 3350 hardware, the 3355 hardware. We also offer it as we have two virtual options. So you can run it on an EXXi cluster. So that's a VMware cluster, vSphere. And we just released support for Hyper-V. So any Windows workstation that supports Hyper-V, which is I think pro versions of Windows or server versions of Windows, can also run a Blue Frame VM instance.
Great. And we've got one more, which is actually a really good question that I think would tie in nicely to the discussion of major releases versus point releases. And the question is, how often is the RTAC / Axion required to have a firmware update?
Yeah, that's really up to the discretion of the end user. So our strategy with firmware releases and point releases is we release firmware, featured firmware. So that's a V0 release twice a year. We release point releases in between that pick up any kind of security fixes, any kind of issues that are found in the field, and we release those as no new features, only that addresses problems that customers have found in the field, and we try to keep that window really short. So we try to release those every 2 months or so, so that anything that a customer finds, they make sure they get a resolution to in a very quick manner. And we support point releases on 2 years worth of SEL RTAC firmware. So anything that a customer standardizes on in the last 2 years, any issue that they find, we will address so that they can standardize and stay on a firmware. So let's just run an example. Let's say that you stay, that I wanted to lock on R150. You could stay on R150 for many, many years. And if you ever found an issue in it and that you wanted SEL to address, we would address it, and you would just move up to the next point release, which would again not have any new features, just would have the fix for the issues you've asked for. And then you could stay on that firmware for as long as you wish. So we don't expect that there's really any need to move firmware rapidly. So if your organizational policy isn't, making you upgrade firmware, pick a firmware that you like and stay on it for many, many years.
Great. We've had a couple related questions regarding EtherCAT networking with regards to the Axion modules. Mainly the questions relate to multiple connections for EtherCAT networks, as well as looped or redundant connections. Have we had any thoughts of upgrading or enhancing the functionality to support that?
Yeah, we have definitely thought about it. It's not on our immediate roadmap. So here's where you could, connect two, EtherCAT networks or Axion networks in more of a star configuration and have multiple Ethernet ports serve as a master to an IO. We have not put that in a date, but it is something that we're always thinking about. So if you have a project that is perfect for that, let us know. we're always looking for the right project to do a feature like that. So we've definitely thought about it. It's definitely within the realm of possibilities. So let us know if you got that perfect project for that kind of feature.
Thank you, Darren. Thank you, Chris, and everyone else who joined today. We've now reached the end of the webinar, so I just wanted to mention a couple of things. If your question wasn't answered during the presentation or in the live Q&A at the end, we'll follow up with you via email shortly after. And if you'd like to learn more about this topic, you can visit the RTAC family product page on our website. Also, as Darren mentioned, this is the first of a series of webinars on RTAC and Axion applications. And so we will have one about the DFR application on May 24th. And there will also be a webinar about DER management solutions on May 10th coming up. So we hope everyone enjoyed today's events, and we look forward to seeing you all in those future webinars. Have a great day.